have become an essential threat to our democracy. So consider this justice.
Thank you for listening to Revolution Radio, freedomslips.com, the #1 listener-supported radio station on the internet. Please help support this station so this battle can continue forward. Revolution Radio! The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Hello, everyone. 6:07 p.m. New York time. Obviously, our communications went down. Unknown reasons, unknown fault. This is Collision Course Episode 2, Season 2. I hope that you can hear me now. I am going to check back in with the chat to see if that helped. I'm going to try to get this straightened out. I'm glad that I don't have my guest on right away, and that I have her coming on at 6:30, so I really need to get this fixed, and I apologize for anyone who's listening and waiting and wondering what is going on. I still have a poor network connection. I don't know if I'm going to have to get off again and go check on where my resources are going. Oh, thank you, Patrick English. I appreciate it. I think that someone in the chat room would come over and let me know that the sound came through loud and clear again. I had a problem with my which mic was going which, but no matter. 5:08 p.m. here in Cypress, Texas. 6:08 p.m. in New York City. This is Collision Course, and our talk tonight is going to be about transient objects. Thank you, Hawk. I know I'm live. Thank you very much. Trying to roll into this second show. Had a hard time rolling into it. Took us over 5 minutes to get going. I keep on checking over at Skype. I have a poor network connection. I pray that we keep going. We need the mission to continue. The mission being the discussion of transient objects, objects like Oumuamua. Oumuamua, if you don't know, is that interstellar asteroid / comet that came by our inner solar system, closest approach to the sun, somewhere around October 16th, 2017. We're going to have on the show a scientist, a research astronomer, Karen Meech, PhD from MIT, to talk about her work with Oumuamua, because she has done much research and analysis and been on the front lines of the research and as well the outreach with the information about this interstellar traveler. Still confirming that I have good sound and that we're doing great. Karen's going to come in at 6:30 p.m. New York time, 5:30 p.m. my time, 21 minutes from now. So I think what we could get into is why do we have discussions like this on Collision Course, and where are we going into the future with the show. I really want everyone to know Collision Course was always designed to be a place where two ideas meet, and the recognition of both sides acknowledged, and some sort of debate and analyzation of the two sides determined, and through the input of the surrounding parties, i.e. the observers of the discussion, truths and realizations of actualities can come to light. Doing my research on our guest, Karen Meech, found some interesting information that I will speak to her about, and her discussion with a Native American chief regarding one of the missions that she was a part of. And I'll tell you that was the Deep Impact mission. And we're going to discuss that. We're going to discuss Oumuamua is coming in and it's going out and where it came from and why did I take pictures when I surely shouldn't have. That's all coming up in this next 2 hours of Collision Course Season 2. We're going to roll with some information about Karen, because last week we had Dr. Stephen Fuselier on, and we had him right in the beginning of the show. And I've decided that having someone on at the beginning of the show may not be as productive to me as having someone come in a half an hour into the show, because I actually get to talk about our guest prior to the guest being there, and the guest doesn't have to sit there through my platitudes. And when the guest does get here, we can go ahead and talk what we want to talk about. So the biggest interest for me has always been transient objects, asteroids, near-Earth asteroids, potentially hazardous asteroids, and then the comets, all the different cometary objects that fly around in and out of our inner solar system. One of Karen Meech's specialties is the research of the delivery of volatiles to the inner solar system and to planets like Mars and Earth. And when I speak of volatiles can be any type of liquid, and I guess what I should say is liquid first and volatile second, because water is volatile, and other types of liquids, gases and liquids of other components can be considered volatiles, in that they can be used as a source of energy that can be transferred volatilely. But from my interest in transient objects like Oumuamua, it takes me back to the first days and the first season of Collision Course and the researching of the objects that were coming in and discussion and the interpretations of those objects. Fortunately for me, as I go through the resources that we have available to us today, i.e. the media that is present in today's markets regarding space and theories and science, there is a wealth of information and libraries of data that one can get to and digest if they are so inclined. And that is something that I do constantly and ravishly, and it's something that makes me come on the air and speak to you all about the same process of where a citizen can go out and interpret the same information that scientists are, if only they were to reach out and grasp onto that connection that we all have with these resources. Just like all the other hosts and show hosts and other podcasts and types of that, all their hosts have the opportunity to reach out to the guests that they bring onto their shows, and everyone has their point of interest for their next show. My point of interest really lies in two things. One is discussing with those who are doing research currently on certain topics. So we'll have a series of discussions and interviews, week 2, week 3, and then we're going to introduce a series of discussions about the science that is right on the realm of discovery. So our scientists are all involved with topics of interest, i.e. be it Stephen Fuselier with the IBEX and energetic neutral atoms, or Karen Meech and interstellar travelers, or Renu Mohatra with the Planet 9 search. They all have, in the end, I believe, because it's all contained within our heliosphere, a connection with what science we're going to recognize in the future. It would be easy, let's put it this way, it would be easy to drop bombs on scientists as you have them on your show. When you're outreaching and reaching out to guests who, one, you've never connected with before, and how are you going to connect with them? And two, promise to have a discussion that is viable and relevant to what they're recognizing at the moment. And then three, trying not to step on anybody's toes. At the same time, you have to figure out a process, a procedure to come around full circle with each of the discussions that you have. So in the case of Dr. Stephen Fuchs there, we're going to go full circle when we start bringing up the electric universe and the dimensions. When I say dimensions, the depth of what science recognizes today as physics, and the difference in depth that the future view of physics and plasma and gravity interactions are going to be realized in the future. And that's my belief. And when you talk to the scientists who, like Dr. Stephen Fuchs there, who's doing the research, you find that in their writings, they're saying and speaking words, and this is what's important. They're thinking and then speaking words that leave little to dismiss the fact that they're speaking in electric, in the case of the Dr. Fuchs there, in electric fashion. So when he's looking at interactions at the front of the Earth's magnetosphere, he's looking at electric interactions. If he's looking at particles flying in from an interaction that occurred outside our heliosphere, he's looking at the interaction of the heliosphere and its magnetic field in the inner space medium. So we have to come back and talk about electric universe. So tonight with Karen Meech, we're going to talk about Oumuamua, and I find it interesting through my research, and we're going to have to come back around all the way, because I don't know if I can actually, this first trip around ask point blank, well, if you have this interpretation, but we don't know. I may ask. I think speaking it out loud prior to the event sets up a good result. And what we're talking about is, Karen, the scientific, according to Karen Meech, observations of Oumuamua and what's going on with it. There's its reflectivity, what that means into what its makeup is, its shape, what that means as far as has it ever, is that shape average or atypical in the solar systems as we see them. It's the way it maneuvers itself through space, the speed at which it moves itself through space. These are going to be questions that we're going to talk about with her, because there's lots of interesting answers all about the aspects of magnitude and in the way that it's making its orbit and its tumbling and motions and its orbital path, and why I wasn't able to use a telescope to go out and take a picture. So I guess I can say that now, because then you'll know, because I'll set it up, because I'll tell her. We had some email communications back and forth. Of course, when you try to get a guest on, most of the communications these days are done through email. If you don't know them personally, you reach out through where their operations are, and you send an email, a nice email, and you tell them that you would love to speak to them about a certain topic, and the reason why you speak to them about a certain topic. And would you please get back to me so that I could set you up on such and such and such a day? And you give them 3 days, and if you give them 3 days, then hopefully they'll pick one out of 3. Never pick one day. Never say I need you them one day. So you have communications back and forth. Normally what they'll do is they'll vet you somehow and try to confirm that this is going to be a real discussion and not something that's going to waste their time, because you don't want to waste a person's time, especially these calibers, because I don't want to, for sure. And so in learning about her and what her views are, is that in her discussions and how she talks about it, she'll tell you that it's very unreflective, and that it could be made up of this, and it could be made up of metal. And she says in her discussions that, even though we have these determinations of this, that, and the other thing, we really can't determine whether it's natural or not. And I find that, that's very interesting, because if you're going to, I guess if you're going to bring up the point, and these are recognized procedures for public speakers who publicly speak about important topics. Everyone's been lied to by omission, which basically means you don't get told the truth because they just don't tell you in their discussion with you about what you're talking about. And so you never know when somebody's lying to you, because you just never know, because it'll never come across your ears. And I find it very interesting, though, in that when somebody speaks and they then therefore divulge some information which can be interpreted in some way intriguingly or interestingly, or what do you mean that you can't confirm that it's not natural, it could be artificial? Why would that come up? And the scientists will tell you, though, as a good scientist, everyone has to question. And it's the same reason why they took the radio, they listened to it with the radio songs. They want to be sure that it's not artificial, that it's not something that came from another solar system directed by something else. And so through our discussion tonight, when I do have her on, I'm going to ask her about those interpretations. And so I want to go a little bit about who Miss Meech is and why she would be the perfect person to talk to regarding this interstellar traveler called Oumuamua. Oumuamua. That's Oumuamua. Once you get the spelling right, it's not that hard to say. For the first 15, 20 minutes, I looked at the word. I couldn't pronounce it. Oumuamua. Miss Meech, Dr. Meech, Karen Meech, is an astronomer. She deals with astrobiology, solar system bodies. She's a part of a team for NASA's Astrobiology Institute, the NAI, NASA's Astrobiology Institute, Institute for Astronomy, IFA. Her research areas include comets and their relation to the distribution of early solar system volatiles and origin of terrestrial water. Now, it's important that I get these kind of guests because they are right in the center of the discussion that occurs around all these central research projects. So while you have a central research project under NASA and the Institute for Astronomy, you'll have a group of amateurs, semi-professionals who are also working on the theorem outside of the scope that these folks are working with. So again, her research areas are comets and their relation to the distribution of early solar system volatiles and the origin of terrestrial water. And that's the type of research that's really on top of the list of a lot of things that's going on, because people want to know, how do we get water? Did Mars have water? Where did Mars's water go? She's been involved with Manx comets testing, dynamical models, comet volatiles, comet asteroid space missions, characterizing Earth's primordial water, interstellar planetesimals. That pretty much wraps up everything that she does. and it has everything to do with transient objects, has everything to do with volatiles, i.e. water. H2O, CO, and CO2 is really the comet volatiles that she finds most interesting. She's been a part of the Deep Impact mission, where they took an impactor and crashed it into the comet to discover what was under the surface. And we're going to talk to her about that and get her interpretation of that. I know that we're going to be coming up on break. It's 6:25 p.m. in New York City. Karen's going to be on right around the other side of the break. I do thank you all for listening to this session of Collision Course on revolutionradio.freedomslips.com. Want to say hello to all our friends, Jessica, Stone, Robin, Sean, Bob, Debbie, Joe, New Jersey, Cosmic Obsession, iTelescope.net. All these folks and more on Facebook, Twitter. If they're listening, I want them to know that they're a part of good research done by citizens who have the ability to get things done. We're going to be coming on the other side of the break here, 6:26, so at about 6:31. I'll have Karen on the phone, and we're going to talk about the interstellar space traveler Oumuamua, that flat, cigar-shaped asteroid that came zipping in between Mercury and the sun and zipping right back out, never to return. You'll find out why I went in search of a picture, and Karen said, I don't know why, but you'll never see it again. Excuse me. I thought that was pretty funny. I went to go take a picture, and I didn't know what I was doing, so I'm going to give you some tips about that on the other side of the break. Remember, when we do hear from Karen, she's an astrobiologist dealing with comets and volatiles on comets and the possibility or how Earth got its water. She's also dealt with the Pan-STARRS survey on located at the Haleakala Observatory in Hawaii. Pan-STARRS is the observatory survey that discovered Oumuamua, October 16th, 2017. We'll see you on the other side of the break.
Radio at freedomslips.com. And we'll be right back after this message.
We're in a narco-syndicalist commune. We take it in turns to act as a sort of executive officer for the week.
Yes.
But all the decisions of that officer have to be ratified at a special bi-weekly meeting.
Yes, I see.
By a civil majority in the case of purely internal affairs.
Be quiet.
But by a 2/3 majority in the case of
Be
more
quiet.
I order you to be quiet.
Look, you stupid bastard, you've got no arms left.
Yes, I have.
Look! It's just a flesh wound.
I don't believe I've seen such a display of courage, skill, nerve, grace, and stupidity.
I'll do you for that. What? Come here. What are you going to do, bleed on me? I'm invincible.
You're a loony.
The Black Knight always triumphs.
Roundtable Live Monday through Friday, 1 a.m. till 4 a.m. Eastern Time. Bring your mind, bring your ideas, bring your voice. King Arthur had nothing on us here at Revolution Radio, freedomslips.com.
I'll send for you now.
Enjoy your extra big-ass fries.
You didn't give me no fries. I got an empty box.
Would you like another extra big-ass fries?
I said I didn't get any.
Thank you. Your account has been charged. Your balance is 0.
when you can afford to make a purchase.
No.
I'm sorry you're having
Come
trouble.
on. My kids are starving.
Thank you for tuning in to Revolution Radio. Here at Revolution Radio, we believe in freedom of ideas, freedom of speech, but above all, we believe in freedom of existence through self-reliance. This station is 100% listener-supported, and as a fundraising promotion, I have a kick-ass free gift for a $100 donation. 35,000 seeds. 25 years in the freezer. Long-term storable, 54 different varieties. So if food prices go crazy, the shit hits the fan, or if you just want to save tons of money every year by creating your own food like I do, grab our seed pack special. Just look for the banner on the homepage at freedomslips.com. Don't be a statistic. Don't be part of the problem. Be part of the solution. We need, as humans, to start taking care of ourselves and not depending on the megacorps to provide unhealthy, nasty food. Included in this package is also a DVD with 900 survival and off-grid living documents and the offline home canning how to do everything website all on the DVD. So when you're growing all that food, you know how to can it, store it, preserve it, etc. with all these documents. So thank you for tuning in to Revolution Radio at freedomslips.com. I hope that you will pick up this package and start learning to be free. Revolution Radio, freedomslips.com, where information never sleeps and freedom is one seed that needs to be planted.
What we do in life, that goes in eternity.
Thanks for tuning in to Revolution Radio. Here at Revolution Radio, we are listener-sponsored and commercial-free. But there still are bills to pay. In order to raise some needed funds to cover the cost, our station is offering a silver special.
Hello.
In the continental United States for a $60 donation.
Hey, Miss Meech,
or
Karen, how are
in
you?
Alaska, Hawaii, or Canada for a $70 donation, we will send you an uncirculated 2018 1-ounce pure silver eagle. The $70 donation, the extra 10 is to cover shipping, by the way, outside the continental United States. When making the donation, you must put Silver Eagle promo in the notes on the donation. And thank you for tuning in to Revolution Radio at revolution.radio and freedomslips.com. Without you, there is no less. Revolution Radio, where information never sleeps.
Some of the new information that's coming out as far as you're trying to see
The
where
opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Right. The GEA mission has really opened up the universe in an amazing way with the way it's cataloging the millions and billions of stars the way it is. And not only does it track the position, but in the motion of those stars as well, correct?
Mm-hmm.
Well, that's very interesting to me. The reason why I wanted to have you on, besides the Oumuamua, and basically because of Oumuamua, is that I'm highly interested in these objects. I suppose I should say right away that when we talked in my second email, I said to you that I tried to recover Oumuamua, and I want you to know that it's pretty much just out of sheer lack of knowledge and insight that when I went and took my telescope and put it in the location that Oumuamua would be, I did not know at the time that the relative magnitude was 31 or somewhere in that.
Anything on something that looks like a long period comet orbit or coming from outside the solar system moves very quickly when it's close to the sun. So even a few months away from its closest approach to Earth, it was too faint for even the biggest telescopes.
Right. And for the listeners, and they all know, part of what I do is when we talk about objects like Oumuamua or other comets, is I do have a network and the ability to take some really nice qualified images of the objects. And I think I got overly excited, and I just thought it would be another ordinary everyday object, but you and I both know it's not ordinary or everyday that we have something like Oumuamua come through our inner solar system. Now, when you received the information on October 16th, I believe it was, in 2017, did you have to wait a couple of days until the October 19th date to say, okay, it really is here?
Well, I'm trying to remember the timeline now. It was discovered on the 17th, I believe. It's hard for me to believe I've forgotten some of these details. And then it took them just a couple days to confirm that I think it was discovered on the 19th. And then they looked back into the data from the previous night and found it in the previous night's data, so on the 18th. But with only 2 nights of data, you don't get a very good orbit, so it could have been any number of things. But they immediately started to get follow-up observations because this was part of a near-Earth object survey, and so they always follow up everything that looks like it's moving rapidly with respect to the Earth. And then it was by October 22nd that they had enough data to realize that this really was on a hyperbolic orbit, so it was coming from outside the solar system. And that's when the head of the survey program called me at home and said, I think we really do have something that's coming from outside.
Was speed the red flag? Was it like, this is just going really, really fast, and this is...
Anything close to the Earth will be going fast. And so It really is, you have to get enough measurements over a few days to get the eccentricity or the shape of the orbit.
Right, I should recognize that.
Tons of things that go fast by the Earth, but that by itself doesn't mean that it's particularly exotic. It just means it's close. And this one was close. It passed within about 63 Earth-Moon distances on October 14th.
That is close. And for listeners, what happens with an object like this is you'll have over a period of time is you'll have observations from different places, and when they make an observation, it gives it a pinpoint of a position. And since the object is moving, the more observations you can get, they start taking more positional images. And then once they take the positional images, they can string them together, and they can deliver back an orbit of how it traveled around the sun on its way in and on its way out. Was there anything in its orbit that made it harder to find as it came in? Was it very eccentric? It was very eccentric, wasn't it? Was that something that makes it harder to see things coming?
Well, as I've mentioned before, anything on an orbit like this moves very quickly when it passes closest to the sun. And if it's not like a comet where it's developed a huge tail that gets very bright when it passes close to the sun, this didn't develop a tail, and so it didn't get appreciably brighter. And so it was just very hard to see when it was very far from the Earth, just because it was small and faint.
Right.
And in fact, I just answered an email from someone today who thought maybe they had seen it naked eye in Hawaii at the end of September, and so I looked up how bright it would have been, and that's only a little over two to 3 weeks before it was discovered, and at that point it would have been about 16 million times fainter than the naked eye could see. So it really was too faint to do much until right at closest approach.
Yeah, and
it's a couple of weeks that it was easy to observe.
Yeah, and its outer shell, or what's on the surface of it, is not highly reflective. Or did I read that it was actually a little bit more reflective because of what was on the outside of its shell, or what's on its surface? Is it more or less reflective on an average scale?
More or less reflective than what?
Oh, I guess sand versus charcoal. Is there a difference between sand and charcoal as far as reflectivity?
Well, yeah. I mean, yeah, you know that just from common experience because you see it visually as sand looks kind of pale and brown, and charcoal's really dark, and that's because it's not reflecting much of the light. Charcoal reflects, typical charcoal, I think, reflects about 10% of the light. Comets are even darker than that. They reflect about 4%, and that's because of the organics on the surface. Things like sand, wet sand, might reflect about 20% of the light. Dry sand is even more reflective. We have no idea how reflective this object was. Now, how bright it is depends on both how reflective it is and how big it is. And the only thing we can measure is the brightness. So you have to assume a reflectivity, and then you can get a size, or vice versa. You could assume a size and get a reflectivity. But since all we measured was brightness, we couldn't tell. So we assumed it was like comets with a 4% reflectivity, but that could be wrong.
Now, I know that you've been a part of many different research initiatives and missions, and you've been a part of the data and results of some other missions, one being Deep Impact, correct?
Yes.
And in fact, that was a very big mission for you, and because you had all that going on with an impactor, and then it was the relating of that information back out. Let me ask a question, if I can, on the Deep Impact. Was there any results out of the impact that was just not expected, or was any result expected in a sense?
Well, one of the things that we had hoped to do was to dig a hole in the surface with the impact so that we could look down at the material inside the crater as we flew past and see what the fresh material looked like, because anything that's exposed to space for long periods of time, the radiation alters the surface materials. And so the mission was designed that you'd have the impact and then the dust would clear off and we could look in the crater. And to everybody's surprise, the dust didn't clear off, and so we never did get to look into the crater. And the reason for that was that the comet was much, much less dense than we had expected, so it was taking a long time for the crater to form. So that was very interesting scientifically. And then we had the opportunity with the next mission to fly past the same comet and try and look at the crater and finish our experiment. But much like making a crater into a fresh snowbank, there was not much. It
kind of dissolved.
So, it was very hard to tell where the crater might have been.
But so, and then you have some interest with the Rosetta mission as well, and some work with that. I guess what I'm leading to it together, because these are three main objects. The two comets are definitely different than Oumuamua, but in what you're interested in your research with volatiles, have you come to any realization that you've been able to find the great well of water on any comet?
Well, first, I was not directly involved with the Rosetta mission. I helped out with a few observations from the ground. I was involved with the Epoxy and the Stardust Next missions. All comets are very rich in water. That may be 80% of their bodies. I'm keenly interested in understanding where water comes from that makes habitable planets like the Earth. And so that's the focus of a lot of my science right now. So there were no surprises with comets in terms of the water. Some of the other surprises were how underdense they were, that they really do preserve early solar system material. So that we've learned a lot of details about comets.
I'm going to ask another question about comets.
Sure.
Comets have a location that they sometimes originate from called the Oort cloud. The Oort cloud is located very far away from our sun and from the inner solar system. I was a part, well, I don't know if I can say a part, I was keenly interested in, back in 2010, of a comet named Comet Oumuamua, C2010 X1, I think it was. And this was a comet that, if the orbital path was drawn out, it also had a hyperbolic orbit, though on its close approach to the sun, it soon disintegrated quickly after. Do most of our, or how do I ask this? Do objects that originate from the Oort cloud, if they start coming in toward the inner solar system, is it automatic that they'll have an orbit that will continue to orbit the sun, or could they come in and have hyperbolic orbits, and there's nothing stopping them from having a one?
Well, so far we have not ever had a truly hyperbolic orbit other than the interstellar object. We've seen comets that appear to have slightly hyperbolic orbits, but that wasn't their original orbit. These are comets that have come in and have passed close enough to the giant planets that the gravitational perturbation can alter their orbits. And then they look hyperbolic, but so far, other than Oumuamua, there's been nothing that's come from outside the solar system.
Okay.
So comets that come from the Oort cloud will go back to the Oort cloud, typically. Although if they do get enough energy by passing close to a planet, I suppose they could get ejected. But the hyperbolic orbits are so slightly hyperbolic, I don't know if they're going to escape the solar system or not.
Do you have any feeling on the research into Planet 9 and perturbations of objects out in that area created by an unseen 10-mass Earth object?
I'm certainly aware of it. I've not followed it closely enough to have a strong opinion. I think it's very interesting research, and I hope people keep trying to understand the orbits of these very distant Kuiper Belt objects to see if there's another more massive object out there. I wouldn't be surprised if we have big things out there, because we do have Pluto, we have other Kuiper Belt objects which are almost as big, so to have something else at that size further out. Now, whether or not it's 10 Earth masses, I don't know.
Right.
And I think we're just starting to explore this, and that's very interesting.
Right, and I'm just kind of relating what I've read, so it's purely coming just from another source. I was going to say something. So when we have, if we were, okay, this is what I was going to say. I guess what I'm leading to is, as we're talking about how these objects, in the case of Oumuamua, has an orbit that brings it close into the sun, and then we have objects that can come from the Oort cloud, which reaches out past our heliosphere and come in as a comet. And then we have now these new discoveries of these far-reaching planetesimals like Sedna, like the new Goblin planetesimal and things. It appears that our knowledge of objects that are reaching farther and farther out away from the sun, i.e. ourselves, is really becoming more rich and more rich. We have our spacecraft travelers, the Voyagers, and so forth. But now we're getting to the point where we're having actual knowledge and research done on objects that are a part of our solar system that are now reaching out so far that in some instances, somewhere in the past or in the future, another far-flung object comes from another solar system, and now these two objects are now creating a new interaction and creating a potential for these new interactions that 3 or 4 years ago nobody would really think about, because these new revelations hadn't been, or the new observations and evidence hadn't been brought to light. Do you feel that with these far-flung objects that we could have more of these more interactions that could actually affect some of these larger objects out in our far-flung regions? or are the large objects, these planetesimals, the goblins and the sednas, they're pretty set in their orbits.
Yeah, they're not changing their orbits. We are now getting the ability with big surveys and bigger telescopes to see what's out there, but they're not changing per se because of the new things we're discovering.
Yeah, I guess
what's out there.
Right, and we won't know until our technology or our vision or our ability to see farther and farther, and eventually time will tell. Time is the visionary of us all for the most part, because in time we get a chance to see it all. We're coming up on 3:51 your time in California. My time is 5:51 p.m. It is 6:51 p.m. in New York City. We have another 4 or 5 minutes with Miss Karen Meech. Again, I really am appreciative of you to take the call. I know that it must, if it's not, to come on and speak with somebody that you have never spoken to before. I know it takes someone with initiative and motivation to do that, and I really do appreciate both those things. Now, I want to know, or give you an opportunity for folks who were just coming upon this information, because really what I brought you on about was Oumuamua, is when we look back into its past, which means where it came from, what will it tell us about how our solar system may have formed? Because we know that in its shape it's a little bit unique, and most objects that that come from a creation of a solar system tend to have different types of shapes. So what's our ability to learn from Oumuamua as we take it back to where it came from?
Well, today we've got the leftover evidence in our solar system of the processes that gave birth to the planets. And we have theories about how it works here and elsewhere. And with today's best technology, we can't really look at the earliest stages in other solar systems just because we don't yet have the ability to resolve those fine details, nor can we get at the chemistry. The assumption is the physics and the processes will be the same elsewhere. But what I thought was really exciting about Oumuamua is suddenly we have a piece from another solar system, from that early aspect of planet building, that was delivered to us nearby so that we could study it in a little bit of detail during a couple of week period. So the hope was to see if that same process that we've tried to figure out about how our planets got assembled actually happens exactly the same in other solar systems. And, the hint was that, the shape is a little bit different, so maybe there's some sort of process that caused that. There was a hint that maybe the chemistry was different, and you wouldn't expect things to be identical from system to system. So it was just our first look, and so everyone is anxiously waiting for the next one to be discovered and hoping that we'll have a little bit longer to observe it.
That's wonderful. And it's the surveys such as the Pan-STARRS surveys that will be doing the a lot of the grunt work. I'll call it grunt work because it's there every day that it can, imaging space to allow us an opportunity to see inbound objects and have an opportunity to do the research, hopefully on the way in rather than on the way out. I have a question about Pan-STARRS because I don't have a lot of knowledge exactly how it works. So in its survey, the telescope operates on a nightly basis, and it's taking images of a survey location. And is that telescope like any other telescope? It returns a set of FITS images, and when I say FITS images for the folks, it'd be an image that was used for science, taken by telescopes and such. Rather than it saying .jpeg, it says .fits, and it has astronomical information in the header on the image. So does the Pan-STARRS telescope take images that are fits and then they go into a database and then someone physically has to go through and observe, or is it run through a program and then it gets to physical hands?
Well, these are
Did you explain that?
FITS images, and they're short exposures, so there's a lot of them taken every night. So they are automatically processed each night. And I know there's some automated software that can analyze and assess whether things are moving objects. But there's always a human each morning that has to look at the images because, sometimes you can get cosmic rays, which are just high energy particles that go through the detector, and it creates a splash of light that may look like an object, and the software might think it's a moving object when it's not. And so a human will go through and look and say, yes, that truly is a moving object, and they'll try and classify it as a point of light, namely an asteroid, or possibly a comet. And then things go to other telescopes for follow-up, and then they're immediately reported to the microscope.
Do you know how long the exposures are? Because that interests me.
I'm thinking on the order of 30 seconds.
30 seconds. See, I'm just an amateur person who has an ability to go out and take pictures with some telescopes. I've dealt and worked with iTelescope.net, so they have their network of telescopes all around the world, and I've become friends with them folks there. And besides our observatory that I have here with my father-in-law in Texas, have access to this great tools. So whenever I can get inklings of how others are doing it, it really it helps me, because I get stuck doing my exposures too long when they're doing it. Long exposures are good for pretty pictures, but they're not very good for objects moving very quickly.
We're an anarcho-syndicalist commune. We take it in turns to act as a sort of executive officer for the week. But all the decisions of that officer have to be ratified at a special bi-weekly meeting, if let's see, by a simple majority in the case of purely internal affairs, quiet, or by a 2/3 majority in the case of more than one. I order you to be quiet. Look, you stupid bastard, you've got no arms left. Yes, I have. Look, it's just a flesh wound.
I don't believe I've ever seen such a display of courage, skill, nerve, grace, and stupidity.
And this is
What? Come here.
Thank you so much.
What are you going to do? Bleed on me? I'm invincible! You're a loony. A black knight always triumphs!
Roundtable Live, Monday through Friday, 1 a.m. till 4 a.m. Eastern Time. Bring your mind, bring your ideas, bring your voice. King Arthur had nothing on us. Here at Revolution Radio, freedomslips.com.
Thank you very much. I'll send you a thank you email, and you have a wonderful afternoon.
Enjoy your
extra big-ass fries.
You didn't give me no fries. I got an empty box.
Would you like another?
Extra big-ass fries.
I said I didn't get any.
Thank you. Your account has been charged. Your balance is 0. Please come back when you can afford to make a purchase. No. I'm sorry you had
Come on.
638 New York.
My kids are starving.
558 Cypress, Texas. Talk about Oumuamua. Talk about some cometary missions.
Thank you for tuning in to Revolution Radio. Here at Revolution Radio, we believe in freedom of ideas, freedom of speech, but above all, we believe in freedom of existence through self-reliance. This station is 100% listener-supported, and as a fundraising promotion, I have a kick-ass free gift for a $100 donation. 35,000 seeds. 25 years in the freezer. Long-term storable, 54 different varieties. So if food prices go crazy, the shit hits the fan, or if you just want to save tons of money every year by creating your own food like I do, grab our seed pack special. Just look for the banner on the homepage at freedomslips.com. Don't be a statistic. Don't be part of the problem. Be part of the solution. We need, as humans, to start taking care of ourselves and not depending on the megacorps to provide unhealthy, nasty food. Included in this package is also a DVD with 900 survival and off-grid living documents and the offline home canning how to do everything website all on the DVD. So when you're growing all that food, you know how to can it, store it, preserve it, etc. with all these documents. So thank you for tuning in to Revolution Radio at freedomslips.com. I hope that you will pick up this package and start learning to be free. Revolution Radio, freedomslips.com, where information never sleeps and freedom is one seed that needs to be planted.
What we do in life echoes in eternity.
for tuning in to Revolution Radio. Here at Revolution Radio, we are listener-sponsored and commercial-free, but there still are bills to pay. In order to raise some needed funds to cover the cost, our station is offering a silver special. In the continental United States for a $60 donation, or in Alaska, Hawaii, or Canada for a $70 donation, we will send you an uncirculated 2018 1-ounce pure silver Eagle. The $70 donation, the extra 10 is to cover shipping, by the way, outside of the continental United States. When making the donation, you must put Silver Eagle promo in the notes on the donation. And thank you for tuning in to Revolution Radio at revolution.radio and freedomslips.com. Without you, there is no us. Revolution Radio, where information never sleeps.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Good evening, everyone. It's Francis on Collision Course at 7:02 p.m. New York time, 6:02 p.m. here outside of Houston, Texas. Thanks for listening in. Hopefully you got to hear Miss Karen Meech from the NAI at the University of Hawaii. She's working with Pan-STARRS on research for Oumuamua. Their work right now is interested in where Oumuamua came from on its path into the inner solar system. She also deals with a lot of other types of transient bodies like comets and asteroids and the such. She's had some side participation with the Rosetta mission. She's had participation with Deep Impact, where they impacted a comet with a copper projectile to see what the comet was made of. There's one important thing that I wanted to say. Karen has done a TED Talk about Oumuamua, and I've read in a number of places, because Oumuamua is a Hawaiian name, and nobody that I know of, including myself, could tell you what Oumuamua meant without going and looking it up, or if you relied on what people like Karen Meech are telling you that what it means. I'll tell you that the scientific community and academia, including Miss Meech, will translate Oumuamua as a scout or messenger from distant past reaching out to us. She says they researched via a navigator and a linguist of Hawaiian culture to come up with this name. It initially had the name Rama, and I'll have to look to see what that Rama means, but it doesn't sound good. Anyways, maybe I'll do it right now once I say this. But so they're saying in their presentations and in their conferences, Oumuamua, we researched it, got the help of a navigator and a linguist, and it means scout or messenger from distant past reaching out to us. Well, again, we are having radio shows because we are the researchers, and we're willing to go out there and do a search. And so if you search Oumuamua and what it means, you have actually a hard time finding anything outside of the status quo. Then there's website Ulukua, I think it is. Ulukua. Ulukua told us that Oumuamua means the foremost soldier or the front rank in battle. I did not make that up. I guess I might have to go back to be sure that whoever interpreting the name is correct, whether it's the Ulukua, if the Ulukua page is right, or if our scientific academia is correct, because Science says scout or messenger from distant past reaching out to us. It's like, hello, I'm going to go by. Instead of the foremost soldier or the front rank in battle. Space Force, anyone? If you didn't know it, Donald Trump brought up the idea of a Space Force so that we have our ability and plan of action if we need to have an action in the space outside our atmosphere. I want you to know that it's important that as citizens of this dear Earth of ours, we should also have a Space Force. Citizen Space Force is a force of informed individuals sharing data about the events outside and inside our atmosphere. October 16th is around the day that the news hit about Oumuamua's travels inside and outside of our solar system, or at least it's soon to be travel outside of our solar system. We are surely trying to look back where it came from. Interesting. Or science. Interesting science. We have someone on air. If I was to rank that person in talkability, I would give it a 6. All these have to do with, are there omissions? Are we being omitted too? But I didn't want to make that up, and I'm going to move on to an article. But science and academia went to one Hawaiian navigator and one linguist. One scientist, one navigator, and one linguist went into a bar talking about an interstellar traveler. 3 came out with the word Oumuamua in their mouth. They said it was a scout or messenger from distant past reaching out to us, but they had the interpretation wrong. It was actually a foremost soldier in the front rank in battle. We'll have to see. We're going to stay updated about Oumuamua as we learn about where it came from. Will there be more? Oh, there's a second part to that. So we have part 1, a foremost soldier or the front rank in battle. And then there's part 2, a scout. One sent forward before a battle to discover the position of the enemy. I just said enemy. I didn't even read that one. Are you kidding me? Are you kidding me? It's not even real, but it is real because Ulukua. I'm gonna have to go look that up. Ulukua. That's ridiculous. I only got there's 2 parts to it. I read the first part. I didn't scroll up far enough. I only had the foremost soldier in the front rank in battle, and now in the second part it says a scout one sent before a battle discovered the position of the enemy. Are we the enemy? And I guess all that information can be hidden inside some cometary research. I'll tell you, last week's guest, Dr. Stephen Fuselier, he was an interesting fellow. He was working with the Southwest Research Institute on IBEX. That was where he went to work, but he was actually working for Lockheed Martin and the high technology department because they were working a joint venture with the Southwest Research Institute on IBEX. And I didn't know that up until our discussion last week. During the discussion, I didn't feel it was necessary to bring up or ask him questions about his work with Lockheed Martin, but I did want to recognize that is, again, part of our full circle as we move around all these topics. We'll have shows that highlight all that we've learned, all that we can trust, all that we must learn, and where it's going to take us. As far as the interpretation or the translation of Oumuamua, come on. Is he friend or foe? Oumuamua is the first known object of interstellar origin to have entered the solar system on an unbound and hyperbolic trajectory. That was something else I found quite interesting. When she said that Oumuamua was the only hyperbolic object, I know that's not true. But Lenin didn't get an opportunity to travel out because it got kaput and wasted all its water, I guess. But for her to say that that was the only one, I beg to differ. It's the only object to have interstellar origin and to have entered the solar system on an unbound and hyperbolic trajectory. With respect to the Sun 1, our Sun, various physical observations collected during its visit to the solar system showed that Oumuamua has an unusually elongated shape, i.e. that cigar, and a tumbling rotation state, and that the physical properties of its surface resemble those of a cometary nuclei. They recently discovered that Oumuamua was speeding up on its way out. You can't speed up. How are you speeding up? The only way it could speed up in their interpretation is if it was a comet and it was outgassing. So they said it must have commentary, must be a comet because it's going faster than it should as it passed the sun. They were unable to confirm that it wasn't artificial. They showed that the physical properties of its surface resembled those of a cometary nuclei, which plays into their speeding up, even though it showed it had no evidence of cometary activity, which, if it doesn't have any cometary activity, why is it speeding up? The motion of all celestial bodies are governed mostly by gravity. And again, we'll see this more and more and more. These things are saying mostly by gravity. Mostly. Gravity's become mostly. But the trajectories of comets can also be affected by non-gravitational forces due to cometary outgassing. But they just said Oumuamua doesn't have any. Because non-gravitational accelerations are at least 3 to 4 orders of a magnitude weaker than gravitational acceleration, the detection of any deviation from a purely gravity-driven trajectory requires high-quality astrometry over a long arc. And astrometry is just about observations. If you have observations, you can do astrometry. Anybody can do it. I can do it. You can do it. I'll show you how to do astrometry. 2 free software programs, zippity zoop zoop. Go out there, take yourself a picture with a FITS image, bring it back, send it over to nova.astrometry.net, bring it back, put it in DS9, boop, boom, you get astrometry. Astrometry is just all about finding the specific coordinates of a particular moving object or on one that's not moving. You can do either or. And as far as Oumuamua, as a result of non-gravitational forces that have been measured in only a limited subset of the small body's population, here they report a detection that is a magnitude weaker than gravitational acceleration. The detection of any deviation from a purely gravity-driven trajectory requires high-quality astrometry over a long arc. As a result, non-gravitational effects have been measured only on a limited subset of small body population. Here we report the detection at a significance of 30 ohm. Of non-gravitational acceleration, the motion of Oumuamua. We analyze the imaging data from extensive observations by ground-based and orbiting facilities. This analysis rules out systematic biases and shows that all astrometric data can be described once a non-gravitational component representing a heliocentric radial acceleration proportionate to r-2 or r-1, where r is the heliocentric distance, is included in the model. After ruling out solar radiation pressure, drag, and friction like forces, interaction with solar wind for a highly magnetized object. There we go. Let's stop. Keywords. Everybody say it. Magnetized object. Let's use it in a sentence. Interaction with the solar wind for a highly magnetized object, and geometric effects originating for Oumuamua potentially being composed of several spatially separated bodies or having a pronounced offset in between its photocenter and center of mass. We find comet-like outgassing to be a physically viable explanation, provided that Oumuamua has thermal properties similar to comets. So they go through the description of the proponents of outgassing, i.e., well, if it was a comet, then what we're seeing is expected. And since we're calling it a comet, we can lay in the comet's math and then set up the result that we want. Yet we have to assume that that is what's actually occurring, and that's what they said. And I said, if. When science says if, they're doing a comparison to similar or unsimilar objects. Deep impact. Our guest tonight, Ms. Meech, was a co-investigator on the 8th NASA Discovery mission, Deep Impact, launched in 2004, heading for Comet P Temple 1 in 2005. At that time, the mission goals were to create an impact crater utilizing a 350 kilogram copper impactor. Okay, so 350 kilogram times 2, that's 700 and a half, 125, 825 pounds, give or take. Refrigerator. Copper, send it into the... Now, and here we go. See, because I have all my friends have their interpretation of the universe, and they research their favorite interpretations diligently. They have their information sources that they love best saved. They go there and visit it regularly, and I've listened to them, and we're going to understand the depth of change in between today's science and tomorrow's science. Because here we go. They use a copper, 825-pound copper impactor. Now, it could have been made of anything. It could have been made of, because it's just the impactor. It's there to make a hole. As Miss Meech said, it was only designed there to make a hole so that when they could fly by later, they could look in the hole and they could see what was made up inside of it. I.e., they were hoping to find something shiny and wet. Well, instead, what happened is it made a big, huge dust cloud that didn't go away. And then when they finally were able to come by after the dust had settled, it filled back in the hole that they created with a big copper weight. Why would they make it copper? Is it important that it would be copper? Were they looking for something with it being copper? It's interesting. We're gonna have to research more about that. And again, Collision Course is about bringing these sciences to light for the public. This is my free speech. This is your free speech. Take a moment to click on the donate button and donate to revolutionradio.com, freedomslips.com, revolutionradio@freedomslips.com, or revolution.radio. I find all those pages work just as well. Click on a donate button and donate today, because Revolution Radio is a listener-supported radio station, and it relies on listeners to keep its servers running. While we can have as many hosts as we can handle, we still need people like you to donate, people like me to help. We all try to do our part. Please do the same. If you want to hear interesting interviews from scientists on Collision Course every Saturday night from 6 to 8 p.m. in New York, 5 to 7 p.m. in Texas, on Studio B, we'll need to have Revolution Radio around to host it. Thank you for listening. And now back to your show. Hey everyone, it's Francis, Collision Course. you know, right now the time is 6:21 p.m. in Texas, 7:21 p.m. in New York. We were just talking about the Deep Impact mission and how the goal was to drop a 350 kilogram copper impactor to watch the formation of a crater and to dig below the surface of that crater to see the evolved materials of a comet and study the pristine interior. One of the goals as a science team member, Miss Meech, is there to coordinate all of the ground-based observing for that mission. So when we talk about Miss Meech, our guest earlier, she is a true and blue astronomer. Deep Impact was famous for its July 4th, 2005 planned impact with Comet Tempel 1. It generated a brilliant flash of light. Impact generated a brilliant flash of light. It was later discovered to be ice and dust debris ejecting from the fresh impact crater. The Deep Impact mission was the first attempt to peer beneath the surface of a comet. Her research is about the water. Where did we get the water from? Deep Impact, which released an impactor on Comet Tempel 1 to expose materials on its surface, revealed a number of new findings about comets and their composition, including evidence of water, ice, and organic materials. You know, science has always dictated that a comet has rock, dirt, and ice. Rock, dirt, and ice. Rock, dirt, and ice. Now they have this impactor, and on this portion of material, it says that it released a number of new findings about comets. Basically, what it released was the proof in the pudding of what the scientists were already saying. But I recognize that the actual experiment didn't go according to plan, in that it created so much dust that eventually the returning and falling dust covered the hole back up that they were planning to dig with the impactor, leading many to believe that there was less ice and water on this object than there was sheer dust. And if you're thinking about a icy object, icy objects tend to skin over. And so if there's dust and ice and it'll skin over as it flies by, maybe on its long journey around the sun or another Earth or another object that it warmed up and melted water and created a skin. And so to have the surface of a comet as dusty as it was, so I'm sure that the scientists had to take into effect that result and be less than happy that they got more dust than they got water, according to the impactor. The impactor with the impactor of copper, which is to me very interesting. Why would it be copper? Is there something to do with the electric universe theory? And were they testing a comet as far as to try to make it discharge? What were they doing? Because they really did go in headstrong with big piece of copper, and they didn't really get any results out of it. The mission events: July 3rd, 2005, Deep Impact releases an impactor on Comet Tempel 1. July 4th, 2005, Deep Impact's impactor reaches the surface of Comet Tempel 1, generating an immense flash of light where the impactor struck the comet. February 14, 2011, Comet Tempel 1 is visited a second time by the Stardust Next mission, which studied the area where Deep Impact released its impactor in 2005. Key discoveries: July 2005, data from Deep Impact shows that a cloud of fine powdery material was released when the impactor slammed into the nucleus of Tempel 1. September 2005, researchers discovered a number of surprising facts about Comet Tempel 1 from the Deep Impact experiment. Tempel 1 has a very fluffy structure made up of a fine dust that is weaker than a bank of powder snow, but that's held together by gravity. Okay. What appears to be impact craters can be seen on the surface of the comet. A huge increase of carbon-containing materials were detected when analyzing the comet's ejection plume, indicating that comets contain a substantial amount of organic material and may have brought that material to Earth at one time. And the comet's interior is well shielded from solar heating. So I guess they're saying that what I said doesn't count because we won't heat it up enough to get to the water. That's supposing. Meaning that the ice and other material deep within the comet nucleus may be unchanged from the early days of the solar system. And again, there's science, they're speaking science that's unproven. They have no idea. If you're no idea, then you should say, our theory is there must be ice inside, even though we whacked them a couple of times and haven't gotten anything back. September 2005, astronomers using data from NASA's Spitzer Space Telescope and Deep Impact come up with a list of compounds thought to be the recipe for planets, comets, and other bodies in the solar system, including other solar system. Included are silicates or sand, clay, carbonates, iron-bearing compounds, and even aromatic hydrocarbons, which means you smell goods. Come smelling fine. In February 2006, the Deep Impact team discovers water on ice on Comet Tempel 1. Scientific instruments was the high-resolution instrument HRI, medium-resolution instrument MRI, Impactor. Extra water article includes the water and life connection. There is research going on about how the human situation is in tune with the water environment that we are a part of. There is research that's out there that says we may be more water orientated than our current situation speaks of. That we humans and basically all life on Earth are aqueous. Our bodies, cells are made mostly of water, solution, and membranes. Our chemistry is responsible
Revolution
for
Radio at freedomslips.com.
reproduction,
Right back
and life. And that water and its chemical properties
Wadia will remain a
and the way it
dictatorship.
responds to changes, including temperature.
Oh, be quiet. Why are you guys so
Make it
anti-dictators?
the
Imagine
ideal
if America was a dictatorship. You could let
medium
1% of the people
for
have all the
our
nation's
own
wealth.
biological
You could help your rich
activity.
friends get richer by cutting their taxes and
Water
bailing them out when they
is
gamble and
such
lose.
a key
You could
player
ignore the needs of the
and
poor
so
for
much
healthcare
so
and education. Your media
that
would appear
it
free,
is
but would
considered
secretly be
essential
controlled by one person and his family.
for a
You could wiretap
recognizable
phones.
life.
You could torture foreign prisoners. You could have rigged elections.
Unlike
You could
many
lie
other
about why you go to war. You could fill your
compounds
prisons
that
with
we
one
have
particular racial group, and
surrounding
no one
us
would
in our
complain.
environment.
You could use the media to
Water
scare the
expands
people
upon freezing.
into supporting policies that
And
are
its
against
ice
their
flows.
interests.
Tune in Monday through Friday, 4 p.m. Eastern
It's a
Time
property
for
that
Liberation
is
Nation with Deacon John,
crucial
where
for the
America comes
persistence
to hear the truth.
I know
aquatic
this is
habitats
hard for you Americans to imagine, but please
under
try.
freezing surface conditions. In addition,
Ohio Exo
Water's
Politics will be
role
on
in
from 4 to
biology
6 p.m. Eastern on Studio
plays
A.
a predominant
Mark Schneider will have guests
and
on that will
determinant
discuss many
role
important topics,
in
including the state of
geology.
the world today. However, much of the show will be dedicated to the writings of Edward Albert Meyer. Let me read a short passage from one of his writings. Love is the highest principle of creation, and through it, everything exists in absolute logic. All of nature in its indescribable splendor is nothing but the love of creation, which is expressed visibly. The love of creation is everywhere, because without it, nothing at all would be able to exist. Please join Mark on Ohio Exopolitics from 4 to 6 p.m. Eastern on Studio A.
is no secret that the so-called mainstream media is best described as controlled propaganda. Countless news stories are either totally ignored or spun with half-truths, and because of this, essential facts and vital information are often compromised. Join Dr. Ott every Friday night on Studio B at 10 p.m. Eastern and learn why The Story Behind the Story was nominated for a Peabody Award in its second year of producing unparalleled broadcasting excellence in 1997. That is, if you really care about learning the truth.
Transcending time and space, let us take you to the place inside your mind where thoughts divide and mysteries unwind. Join us every Monday evening right here on Revolution Radio at freedomslips.com from 8 to 10 p.m. Eastern Time. And you will catch the Fenton Perspective with our great host, Lorian Fenton. Come listen in as she shares her amazing stories from the past to present, along with all of her guest secrets to the future. That's the Fenton Perspective every Monday evening right here from 8 to 10 p.m. Eastern Time, only on Revolution Radio. Oh, and you don't need to expect us. We're already here.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Hey everyone, Francis, 7:34 p.m. New York time. We're just on the other side of a break. We're either coming to the end of the break or we are already there. Thank you for listening to the end of the second hour of Collision Course, Season 2, Episode 2. Earlier we had our guest, Miss Karen Meech, and we talked about the interstellar traveler, cometary asteroid Oumuamua. Be sure to go to the archives page and listen to tonight's episode simply by signing up to listen to the archives of Revolution Radio at freedomslips.com. The archives contains all the past history of shows. Get with Nighthawk. He has shows going way back that you can buy on a zip drive, a little flash drive. Lots of ways to take part in the shows that occur here on Revolution Radio, listening to old shows, waiting for new shows to get onto the archive. You must be a part of the archive subscription. Very affordable to get all that content every day, every month. Do that. And you can hear my show, Collision Course, every Saturday from 6 to 8 p.m. New York time, where we talk about space. Today we talked about Oumuamua, interstellar traveler asteroid comet, with Dr. Karen Meech. We're talking about comets and their ability to travel with water from one place to the next, and how water plays such an important role in our evolutionary process and our environment. And if we find out that water is quite rare in the aspect of as it is here on Earth, that will make us more interesting to potentially other interests other than our own. We talked about Oumuamua. This object came from outside our solar system. Science and academia are currently working to map where it came from In my research before this show, I realized a conflict of translation of the meaning of Oumuamua, where academia makes it sound like there's a nice guy coming. There's other interpretations of translations that make it sound like a scout trying to find out where the enemy is located. So, besides that object, we do have comets that come and interact with our inner solar system. We could one day have an interstellar comet. Imagine a comet the size of a city coming from outside our solar system, traveling in the same direction as Oumuamua. Only we get to recognize it a month or two before it gets here. What will we do? Will we know where it's headed? Will we know why it's coming? What its path is? Or will it come, or will our realization of its coming be too late? Much like Oumuamua, we didn't realize it was in the solar system until it was on its way out. Till after it made its closest approach to Earth at 15 million miles, which in universe and scale is quite close, 15 million miles away. Oumuamua, very large. And we didn't know it until it was on its way out, a day or two past. We have those happen regularly too. We can go back in history and find objects that we just don't realize until after they're gone, because it's in the delay of the information. The telescope takes the picture goes into the software spits out a picture, a human's got to look at it. Zing, bang, boom, and we're 3 days late and seeing something come in because it took 3 days for it to find it. The University of Hawaii, in regards to Oumuamua, is located in a unique island setting, and this is the Pan-Stars too. And because of this, has developed several centers of research excellent, including the Institute for Astronomy and the School of Ocean and Earth Science and Technology, SOEST, which includes the Hawaii Institute of Geophysics and Plantology, the Department of Geology and Geophysics, and the Department of Oceanography. The NAI team takes advantage of the University of Houston's Pacific location, University of Hawaii. My son goes to the University of Houston. Great kid. Dean's List. Wonderful. Love you, Sean. The University of Hawaii's Pacific location, the excellence of these specialized research units, and the University of Hawaii's unique research facilities build upon a new interdisciplinary research and education framework around the water theme. Water in the cosmos, water in is the medium in which the chemistry of all life on Earth takes place. So it's easy to postulate that if water is everything about life on Earth, then we must find water elsewhere to either maintain the life that started on Earth or to look for life that is not Earth originate, or not from Earth. Water is the habitat in which life first emerged and in which much of it still thrives. Water has modified Earth's geology and climate to a degree that has allowed life to persist and present epoch. Water, to me personally, is an important. I mean, if I want to relax, I need to be near water. I mean, if I want to relax, I place myself near water if I'm able. Anything that has to do with water, I'm down for. And I've heard research about maybe we came from another place that was a lot more water bound, and we were actually living our life water bound. But that's yet to be proven out. The theory is nothing but a theory until it's proven out. Studies of interstellar clouds such as IC 1396 is going to teach us about the presence of water molecules in star-forming environments. These are the nebulas of the universe. But in that, again, we think about what kind of science are we going to be following? Are we following the electrically charged universe where electricity and magnetism rules the day, and therefore the lack of electricity and magnetism allows gravity to take over. It's a blending of electric and gravitational force unified theories. Our sun and planetary system most likely formed in a very similar environment. Studies of those clouds show us that water is not uniformly abundant, and its incorporation into Earth-sized planets is not necessarily constant, which means Earth is unique. Water forms in the interstellar medium and in the denser molecular clouds that give rise to star-forming regions. The difference in the relative abundance of elements and their isotopes and in the chemical reactions that take place amongst the gases and the abundance of water in those regions. Science will use new sub-millimeter and infrared facilities on Mauna Kea to quantify the presence of water ice in the interstellar clouds and to characterize and understand the environments where water exists in space. Because of the high abundance of water ice in the interstellar medium, water has played a vital role in physical and chemical processes that have led to the formation of astrobiologically important molecules. The University of Hawaii's National Astronomy Institute team members will perform cutting-edge laboratory chemistry experiments to address for the very first time the important questions of how the basic life ingredients form out of non-living matter in extraterrestrial environments such as molecular clouds and the crucial role that water plays in their formation. Comet ices preserve a chemical record of this precursor interstellar material, and detailed remote measurements of the hydrogen isotopes in these icy bodies has shown that comets contributed some, but not all, of the water to Earth's oceans. Important to note, there's these different avenues of information and how they relate the information regarding water and how Earth God is water is where the discussion will lie, because other discussions and other researchers will say, well, no, all the water came from comets. It must have come from comets because there is no other water. But here it shows that in the inner space medium, there are water molecules. Comets, also rich in the organic materials that are essential to life on Earth, will be investigated, and the inventory of both organics and ices will be determined. There will also be research done on meteorites. Through the use of laboratory equipment, they have studied minerals and meteorites that are formed as a result of interaction with liquid water early in the solar system. The minerals preserved inside the asteroids represent a record of aqueous activity in their parent bodies, and that information will provide an abundance of data regarding the distribution of water and the primordial solar nebula. So in that place where our sun was created, an asteroid may be able to tell us how much water was present when it was snapped off a larger part or thrown into its orbit, eventually coming to Earth later on with all its rich information about water and ice that it traveled through or was made up of. The cosmochemical record in meteorites shows that a large range of water abundance existed in the early solar system, perhaps because of the removal of water from the warm material of the primordial nebula. Planets forming from planetary building blocks from different parts of the early solar system would have received different inventories of water because of their location. Comets and meteorites impacts play a role in helping bring this water not only to Earth, but to our neighboring planets, Venus and Mars as well. The case of water on Mars includes that Mars is the planet most resembling Earth. It also contains an unambiguous and it also contains an unambiguous evidence for the activity of past and present water. Just think of the polar caps on Mars. We know now through images taken by our friends, including Damian Peech, his images show clear and distinct polar caps, north and south, white as snow. Now, I might have to determine, or someone will have to tell me, is that white all water, or is that white all carbon dioxide, or some other volatile? But these planets, this planet, Mars, where at one time we were wondering if there was any water ever on Mars, till now we can see clearly it has polar caps on both sides, and what was the discussion about for all those people who could operate a telescope, planetary telescope, and take a picture? That ice just didn't show up. But our understanding of it, and the citizens' understanding of it, and the layman's terms of it, and us as researchers, without the degrees, without the funding, the citizen researchers, the citizen Space Force who does the work, we will fight through the disinformation and insert our own acknowledged and acquired data to recognize a fully formed theory and possible truth, something that we'll own and stand up for. Mars is the planet most resembling Earth, and it contains an unambiguous evidence for the activity of past and present water. It's probably the most likely to host or have hosted extant or extinct life. Studies of the history and action of water on Mars are of great importance. In this regard, our studies will model the hydrothermal and low-temperature alteration of crustal minerals and rocks by water. Researchers will combine the data from Earth observations and recent Mars missions to assess its water inventory and habitability. So it's not about whether Mars has water, it's in how much water. You know, Elon Musk wants to shoot a nuclear missile to the North Pole of Mars to terraform the planet. My brother says, that's a stupid idea. I said, it's an idea. So what about all the radiation? I said, it'll be at the North Pole. Won't bother anybody. Earth observations and recent Mars missions to access its water inventory and habitability included the detection by the Mars Global Surveyor of copious ground ice from recently carved gully-like landforms raises the possibility that liquid water is close to the surface of present-day Mars. And there it is. A couple years into the research, and we have water on Mars by the oceans full. An X-ray image of a piece of the Murchison meteorite, a primitive water-rich early solar system leftover. This type of meteorite contains a high abundance of water-bearing minerals and organics. It could be a source of water in the inner solar system. Water has also been involved in life since its first appearance on the early Earth. The leading theories of the origin of life postulate that prebiotic chemistry occurred in low-temperature aqueous solutions that were supplied with prebiotic molecules by atmospheric chemistry, or in hydrothermal brines produced by high-temperature water-rock interactions, like at the deep water thermal vents, deep water thermal vents. The first 3 billion years of the drama of life on this planet were played out entirely in aquatic environments. Water is also involved in geochemical reactions that maintain surface conditions permissive of life. The presence of water significantly alters the properties of minerals in Earth's crust and mantle. something crucial to the operation of plate tectonics. Without water, we don't have tectonics. These geologic processes in turn drive many of the biogeochemical cycles important to Earth's habitability. Investigating the water rock chemistry of deep oceans and its relations to habitats for life, reactions between silicate rocks and water, particularly at high temperatures, produce aqueous fluids and altered mineral surfaces whose chemical imbalances are potential energy sources for life. It is in the interaction of water, minerals, heat that life is born. Besides water, life also requires a source of carbon and nutrients and an environment that is conducive to the propagation of genetic information. Many aquatic environments on Earth are challenging or extreme from the point of view of better understanding of what may limit the origin and persistence of life in aquatic habitats elsewhere in the universe. These extreme environments include lava water interfaces in the Hawaiian Volcanoes National Park, as the magma from Kilauea include lava water interfaces from Kilauea. As the lava from Kilauea flows into the ocean, steam geysers result. High-altitude lakes, such as Lake Waiau on Mauna Kea, and fieldwork in volcanically active Iceland. Volcanically active Iceland. We will focus here on a comparative study of microbial biodiversity and metabolic activity in these extreme aquatic habitats. There must be a model created to support and integrate planetary water and the early history of Earth like planets. Without a model to scale of how life evolved, we'll be unable to understand the makeup of future planets that we'll discover far from Earth or near to Earth. We won't be able to understand how life will be able to form on a planet without a form of water or a moon or planetesimal frozen over by outer space, but yet maintaining liquid water under its surface, teeming with life, active with volcanic activity, where water, minerals, and heat combine. We have those environments now in our solar system outside of Earth. Look at Jupiter's moons, Saturn, and then we have our own Earth, where we have much to learn about our environment underwater, the deepest parts of deepest depths on Earth have been hardly explored. Life has been hardly discovered. There's much to be learned, and there's much research to be done. And it begins, I suppose, in space. If in that we received the ingredient for life from space, we must recognize that it may be taken away from something by space, and or we may be the recipient of something from space that is a new form of life, much different than our own, yet managed to evolve to a place to become a life on Earth, where we might call it extraterrestrial. And in that sense, we might be called extraterrestrials if we take ourselves back to the beginning. Where did we come from? Though they'll say we are but stars. There are levels that start from the star and work its way down to life on Earth. The search for life in water will expand outside the solar system.
Listen to Revolution Radio,
such as the NASA Terrestrial Planet Finder,
right,
capable of detecting and characterizing Earth-sized exoplanets and their environment.
Thank you for listening to Revolution Radio at freedomslips.com. Any commercial advertising you may hear in this program is of the sole discretion and benefit of the host of whose program you are listening to. Revolution Radio does not endorse any commercial products, nor does it accept monetary compensation for on-air advertising of commercial products, nor will it ever. We are and shall remain 100% listener supported. Any product advertising on this program are considered used at higher risk, and Revolution Radio shall not be held liable for any claims or damages received from any product advertised within this program. Revolution Radio, where information never sleeps.
Thanks for tuning in to Revolution Radio. Here at Revolution Radio, we are listener-sponsored and commercial-free, but there still are bills to pay. In order to raise some needed funds to cover the cost, our station is offering a silver special. In the continental United States for a $60 donation, or in Alaska, Hawaii, or Canada for a $70 donation, we will send you an uncirculated 2018 1-ounce pure silver Eagle. The $70 donation, the extra 10 is to cover shipping, by the way, outside of the continental United States. When making the donation, you must put Silver Eagle promo in the notes on the donation. And thank you for tuning in to Revolution Radio at revolution.radio and freedomslips.com. Without you, there is no us. Revolution Radio, where information never sleeps.
Take a look around, kid. What do you see? Homes being foreclosed. People working 2-3 jobs just to put food on the table and still drowning in debt. Don't get me wrong. This country is founded on great ideals and principles. They've all been ruined by the banks. Open your eyes to the banks that are robbing you. You know who my favorite president was? Who? Thomas Jefferson. Because he saw all of this coming and tried to stop it. He fought the banks. JFK too, and they killed him for it. The banking institution is more dangerous than an army, he said. He also said that every generation needs a revolution, Jimmy. The American dream is just that. Just a dream. War is a continuation of politics, only by other means.